In this video, we're going to talk about divisibility so that we can take a number and then write it out as a list of factors, which factors are values that multiply up to a number. But by kind of dividing up the number, seeing what all the factors are, it can give us an idea of what's at kind of the root of the number. And with that, this can help us in the future, especially when dealing with fractions and combining values and things like that. So this is a nice table here of multiples of values. Now this could continue on forever too, like it just stops at 12. But what we can do is kind of recognize some scenarios here. And there's a good list in the textbook that describes how divisibility works and some kind of key rules. And I'll just talk about a few of them here. So multiples of 2, those are even numbers. So if you see an even number, it's going to be divisible by 2. So all of these numbers listed here are even numbers. Multiples of 3, so like we have 3, 6, 9, 12, 15. As we get to larger numbers, like 36, to know whether or not it is divisible by 3, what you could do is take the number and add up the digits. So like 36, if you take 3 plus 6, that's equal to 9. And 9's a much smaller value, and we can recognize that that's divisible by 3. And so with larger numbers, like let's say I had, let's go wild here. How about 5,732? 30. Did I do that right? Yes. Okay. So 5,733. And I wanted to start dividing things out of that. Well, what I could do is add up the digits. So 5 plus 7 plus 3 plus 3. So let's see, 12, 15, 18. And as a smaller value, I know that I can divide that by 3 to get a 6 out. And because that number is divisible by 3, that's divisible by 3. So that's a little trick to know if you can divide 3 out of a number, is add up the digits and see if that sum is also divisible by 3. So if this was, I think I had quickly said a 2 because I was doing the math in my head as I was making this up. So if that had been a 2, that would have come out to a 17, which is not divisible by 3. We can't divide that by 3 and keep it a whole number. So that means 5,732 is not divisible by 3. So that's our trick with 3s. Multiples of 4. The idea is that you can divide it by 2 and then divide it by 2 again. So with larger values, like say we had 48, well, if I cut that in half, that's 24. And then I am able to divide that by 2 as well. So because you can divide it by 2 twice, it's divisible by 4. All right, multiples of 5. The ones place is always going to be a 0 or a 5. Multiples of 6, now we get to a point where we just kind of combine rules. The idea is that it's going to be divisible by 3 as well as divisible by 2. So it needs to be even and the digits need to add up to something that's divisible by 3. 7 is just kind of on its own. 8, you could technically divide by 2 3 times. So like with 96, if I cut that in half, that would be a 48. Cut in half again, that's a 24. And then we could divide in half again, and that's 12. So because we can divide 2 out 3 times, that makes it divisible by 8. 9 is also kind of on its own, or it's divisible by 3 twice. That's how you could think of it. And then 10, if it's divisible by 10, the ones place is always a 0. So really quickly, some rules there. Like I said, if you go to the textbook, they're written out there as well. But those are just some tricks for if we need to divide out or divide down a number, we can have an idea of where to start based on those little principles. Okay. So we have multiple and divisibility kind of go hand in hand with each other. So 15 is a multiple of 5 because we can multiply 5 up to 15. We would multiply it 3 times to get there. And that would mean that 15 is divisible by 5. 15 is also divisible by 3. So when we start talking about listing these numbers that it's divisible by, we're getting to this idea of factors. So if two values multiply up to another value, then those values that we were multiplying together are considered factors. Oh, here's a little summary of those rules that I was just talking about. Okay, so finding the factors of 24. So factors are going to come through as pairings. So what we could do is I typically start at 1, so like 1 and 24. Those multiply to 24. Then I would go, okay, 2, yep, we can do 2 and 12. 3, yep, we have 3 and 8. 4 works as well, 4 and 6. 5, nope. And then if we get up to 6, then we're just repeating ourselves. So I wouldn't want to write 6 and 4 because that's the same as 4 and 6. So what I really do with listing the factors is just kind of start at 1, counting up, and then you are going to reach values that it's not divisible by, and you would just skip over those. But when you want to keep counting up until you get to a point where you start repeating yourself, and that would list all of the factors. Okay, so now what we want to get to is prime factorization. So where we have these factors here, like 3 is prime, but 8 is not. So we would need to do some more work here to get to the prime factorization. In fact, I'll come back to this example. But factors don't only need to be pairs. With the prime factorization, we keep dividing down. We keep listing all of these smallest values that multiply up to this number. So a prime number is a counting number greater than 1 whose only factors are 1 in itself. So like we have 1 and 24 here, but because we were able to list other factor pairs, this is not prime. But like a number such as 17, so we have 1 and 17, and then nothing else, that means that's prime. Okay, so listing up the prime factorization. What we're going to do is when number is written as a unique product of primes. So what we're going to do is just kind of keep dividing down. And there's a few different ways to do this, but I really like this visual of kind of creating a tree. So what we're going to do is start by splitting this with 2 factors. And looking at this number, I just want to see what is this divisible by? And maybe you're seeing a 3 can go in there, maybe you're seeing a 2 can go in there. Order doesn't matter here. We're going to put it all together at the end. So what I'm going to go ahead and do is I'm going to go with 2. So I know 2 goes into there, and that would leave me with 18. Now 18, that can be broken apart. And I could do a 2 and 9. That 9 can also be divided up. It's divisible by 3, and that would leave us with 3. And now I'm stuck. I can't divide anything out. So these numbers, 2 and 3, those are prime. We can't list factor pairings that don't have 1 involved there. So we have a 2, we have a 2, we have a 3, and we have a 3. That's our prime factorization. So if we take 2 times 2 times 3 times 3, and we plug that into a calculator, that's going to give us 36. So like you can see, that would be 4, that would be 9. 4 times 9 is 36. But this prime factorization helps us see what all the smallest factors are. Now you can write it out like this, or you can write it using exponents. So like because we have 2 of these 2's multiplying together, that's the same thing as 2 squared. And then times, and then we have 2 of those 3's, so 3 squared. Either way, it's the same thing. Just pay attention to if they say a specific formatting that you match it. Okay, 81. Let's start breaking this apart. And again, you might be recognizing different factors here, but let's go with So like looking at the 1 there, I know this isn't even, so I can't divide out 2. So then what I would do is go, okay, what's 8 plus 1? That's 9. Okay, that's divisible by 3. So I could list 3 as one of my factors, and that works great. What I can even do here is that 81 is one of our kind of special squares. Like, I know 81 comes from 9 times 9. So let's go that route. But if you go the route of 3, totally fine too. Okay, 9 can be split with 3 and 3. This 9 can also be split with 3 and 3. And then that's my list of prime factors. So I'm going to have 3 times 3 times 3 times 3. Or if I'm using exponents, 3 to the 4th power, since there's 4 of them. And you can always double check these by going to a calculator and just plugging it in and making sure that when you multiply those together, you are getting that original value. Okay, let's just keep doing a few more here. So 124, I'm gonna go with that. I know that's even, so it's divisible by 2. And let's see, that would leave us with 62. That's also even, so I'm going to go 2, and let's see, that's a 31. 31. 31 is prime. There's nothing that divides in there. So what I'm doing is I'm noticing, so it's odd, so we can't divide out 2. 3 plus 1 is 4. That's not divisible by 3. 5 doesn't work. 10 doesn't work. It's not a multiple of 7, which is kind of an odd one out. So we are just stuck, which is totally fine. So 2, 2, and 31 is our prime factorization. Or a 2 squared times 31. All right, 365. So what I'm going to do here is I recognize that that's divisible by 5. So let's go ahead and divide that out. So let's see, that'll be a 6 to get 30, which leaves us with 65, which will be a 3. All right, 63, so 6 plus 3 is 9, which is divisible by 3. So I can divide a 3 out there, which will leave us with a 21, which is divisible by 3 and 7, and that's going to be it. So this one is coming from, order doesn't matter, so I could list this as 5 times 3 times 3 times 7. Totally fine. I'll just organize it smallest to largest, so 3 times 3 times 5 times 7. Totally correct too. Either way, I just got in the habit of going smallest to largest, and it could help out in terms of organization later on. Okay, so that's prime factorization. So it's just dividing up that number and getting primes out so that we can see this breakdown of numbers that are factors of this larger piece. And just to kind of finish it up, so like where we have these factors of 24, I just wanted to go back and say if we wanted the prime factorization of 24, what we could do is start with any of these pairings. So like we could go the 3 and 8. 8 is a 2 and 4, and 4 is a 2 and 2, and that would give us our prime factorization. So that'll be a 2 cubed times 3. But notice if we had started with a different pairing, so say we had done 4 and 6, we would end up with the same thing. So 4 is 2 and 2, 6 is 2 and 3. So we still have 2 cubed times 3. So the prime factorization should always be the same. You can just get there in different ways based on the pairings that you're starting out with.